Hello, Assalamualaikum everyone. Am I audible?
Yes, ma'am.
Walaikum salam, ma'am. You're audible.
Sorry, I'm a bit late. I lost track of time. Okay. Is my screen visible?
Ma'am, it's visible.
Okay, let's get started. Okay, so what did we do last class? Guys, what did we do last class? Somebody please respond. What was covered last class?
MSI circuits and analytics applications.
So I gave you some examples last class. Let's go through some. So construct. Okay, this was one question. You need to construct a 4 to 16 decoder using 2 to 4 decoders. Okay, so whenever you're giving a question like this, always draw the components first. Okay, let's draw the 4 to 16 decoder. So in a 4 to 16 decoder, how many inputs are there? Hello? How many inputs are there in a 4 to 16 decoder?
Four inputs.
4 inputs, and how many outputs?
16.
16, ma'am.
16 outputs. Okay, so from line number 0 to 1, 2 up to line number 15. Okay, so 16 outputs. Alright, so 1 2 to 4 decoder. We have a 2 to 4 decoder. How many inputs does it have?
2.
Right, 2 input, and how many outputs?
4.
4 inputs.
Alright, so this is a 2 to 4 decoder. Okay, so this is output 0 1 2 3. Okay, so this is a 2 to 4 decoder. So 2 to 4 decoder has how many outputs?
4 outputs.
4 outputs. So if you want to build a decoder that has 16 outputs, how many 2 to 4 decoder you would need? Because one 2 to 4 decoder has 4 outputs. So if you need a total of 16 outputs, how many of these would you need?
4.
Right, you will need 4 of them. Okay, so this is the first hint. That how many 2 to 4 decoders do you need? You need 4 of them, because you need 16 outputs, right? Alright, so you have 16 outputs here. Okay, so this is the first hint. So you have 4 inputs. So 4 inputs, let the 4 inputs be A, B, C, D. Okay, let the 4 inputs be A, B, C, D, and yeah, so these decoders will take the input C, D. Okay. So what you do is you connect the C, all the C's together. So C will be connected with this. Okay, this is connecting C, and now let's connect the D's. So we have connected the C's and D's. Okay. Now for AB, we will need another decoder. This AB will control the other decoders. Okay, and now again we will take another 2 to 4 decoder. We will pass A and B through there, and these will work like the enable bits. So when AB is 0, 0, okay, when AB is 0, 0, 1 will pass out of 0 and it will activate this decoder. This will be the enable bits of each decoder. Okay. And 3 will activate, enable this decoder. Okay. Okay, so now individually if you look at the decoder, this is decoder number 1, this is decoder number 2, this is decoder number 3, and decoder number 4. Okay, so individually these are 0, 1, 2, 3 outputs for each decoder, but for overall this will be 0, 1, 2, 3, and this output will be considered as output number 4, 5, 6, 7 up till output number 15. Okay, so let's see how this works. So suppose my input is 0, 0. No, let's do this. Let's say my input is 0, 1, 1, 0. Okay, so for 0, if A, B, C, D is 0, 1, 1, 0, what is this value in decimal? What is 0, 1, 1, 0 in decimal?
6.
It is 6. So if my input is 0, 1, 1, 0, 1 should come out of output number 6 and the rest of the output should be 0, right? So if I give 0, 1, 1, 0, this means from AB it will be 0, 1. Okay, from CD it will be 1, 0. So if you look at this, if I give 0, 1 here, 0, 1 means 1. Okay, so 1 will come out of line number 1 and the rest of the output will be 0. Okay, so if 1 comes out of this, 1 will activate decoder number 2. So in this case, all the 1, 0 will pass inside all the decoders, but all the rest of the decoders will be turned off. Only this decoder will be turned on. Okay, so if I pass 1, 0, all these decoders will be turned off, so 0 will come out of them. Okay, because all of these will be turned off, because these only 1 will pass out of 1, so our output number 1 will only activate decoder number 2. Okay, so this will be turned on and the rest of the decoders will be turned off, so it will be 0. So if I'm sending 1, 0 through CD, this 1, 0 means 2, right? So line number 2 will be activated, which represents line number 6 as the overall output. So 1 will pass out of here and the rest of the output will be 0. Okay, so line 1 comes out of line number 6. So overall this is working like a 2 to 4 decoder. Does anybody have any question? So you might be wondering that how did I come to this approach? Now the gist is, you need to see that when I'm given a 2 to 4 decoder, right? So at a time for each decoder I get 4 outputs. So if you look at the truth table for a 4 variable, you will see that, let's say CD is 0, 0, 0, 1, 1, 0, 1, 1 here. Okay, so for this combination, the output will be from 0 to 4, 0 to 3. So for 0, 1, 2, 3, CD has this combination, and AB is fixed. AB is 0 0. Okay. In the next combination, when AB is 0 1, so when AB is 0 1, the output can range from 4 to 7, and again the combination of CD repeats. So CD goes from 0 0 0 1 to 1 1, and same goes for CD again. The combination for CD is repeated and AB remains the same. That means when AB is 0 1, at that point when AB is 0 1, output number 4 to 7 can occur. Rest of the output cannot occur, because in this in this 4 bits the input is 1 0, and in the rest over here the AB is 1 1. Okay, so AB remains the same for every 4 combinations. So let's say combination number 5. Okay, this is 1 0 1. Here AB is 0 1. So if AB is 0 1, this means that this is combination in this falls in set 2. Okay, so in this part, as long as AB is 0 1, the output can be from 4 to 7. Okay, so for this, decoder number 2 needs to be activated, so that's why the enable bit is connected with 1. That is, when AB is 0 1, output number 1 will be activated, the rest of the output will be deactivated. Okay, so this is how it goes. So for decoders, when you're asked to construct larger decoders using smaller ones, draw the truth table first and always pass the LSB through the input of the later decoders, and you need to understand that the MSB will be used as enable bits of the decoders. Previously we built remember we built we built 3 to 8 decoder using 2 to 4. At that point, since this had 3 inputs, 2 of the inputs went through the decoders, and the MSB, the first input, the first MSB that went as the enable bit. Here the first 2 has to go to enable bits, and for this is there. So if you had only one, like if you had ABC, BC had to go through the inputs, and A would have been used as the enable bit. Okay, so that's why you had only 2 combinations, A or A bar. But when I have AB, I have 4 combinations. That's why with AB there can be 4 different combinations. So when AB is 0 0, this decoder will show the output. When AB is 0 1, this decoder will show the output. So we're using the combination of AB as the enable bit. Okay, anyway, this one was tricky. This was the construction for 4 to 16 decoder using 2 to 4. Does anybody have any question here? Any question, guys? Okay, if not, let's move on to the next example. Okay, can you guys see the question? Alright, so here you're asked to implement a 4:1 multiplexer. Using a 4:1 multiplexer, you're asked to implement this function. Okay, so in the previous class we saw the same example there, but you had to implement a 3-bit it was like this, in terms of 0 3 6 7. Okay, using 2 to 1 marks, right? Guys, last class, was this the question? Can somebody tell me? I think I gave you guys to implement a function. No, it was using a 4 to 1 marks. Yeah, this was the question. Okay, using a 4 to 1 marks, you had to implement this function. So in a 4 to 1 marks, again, how many inputs are there in a 4 to 1 marks?
Four inputs.
4 inputs. And how many output?
One output.
How many selector bits?
Two.
2 selector bits. Okay, so if you remember this function, let's discuss this example first. This function can be easily implemented if it was a 8 to 1 marks, because 8 to 1 marks has 3 selector bits. So we would have passed all these inputs through the selector bits, and we would have connected these inputs to with 1 and the rest to ground. That's how we can do it very easily. But however, if my marks is smaller, that means if my number of selector bits is less than the number of inputs, then I can't put all the inputs in my selector bits, right? I need to put BC here, and A has to be, remember, A has to be manipulated and given as an input through the input bits, and at that point we drew a chart. Okay, last class we drew a chart where we manipulated A and we inserted A as the input, okay, variables or versions of A, and then we implemented this function. But at that point we had only one extra bit. Now, as opposed to this, but however, in this example, if we implement a 4-bit function using a 4 to 1 marks, then again I have 2 bits as selector. So again I have 4-bit input, right? Input is 4-bit, that is A, B, C, D. In such case, what we do is we give CD as selector bits. Okay, CD is given as selector bits, and we need to draw a chart to manipulate A, B. Okay, so we need to draw a chart to manipulate A, B, and CD it will be given as selector bits. So previously, in the previous example, if you look at the chart, we only had A, okay, on the column. So A had only 2 possible combinations, A bar and A. However, if you have A, B, then we have 4 different combinations, that is A bar, B bar, okay, A, B, sorry, A bar, B bar, A bar, B, A, B bar, and AB. Okay, so it can be 0, 0, 0, 1, 1, 0, and 1, 1. Again, for CD, we can have 4 combinations, 0, 0, 0, 1, 1, 0, and 1, 1. Now, when CD is 0, 0, CD 0, 0 means that line number 0 is selected, and whatever I pass through line number 0 will be given as the output. Okay, so this, when CD is 0, 0, this represents input number 0, this is input number 1, input number 2, and input number 3. Okay, next what we will do is we will write the mean terms of the corresponding row and column. But remember, this is not a K-map. Okay, this is not a K-map. What you simply do is you write these combinations. Combinations should be written serially. So this is combination number 0, 1, 2, 3. Okay, mean term 0, 1, 2, 3. This will be 4, 5, 6, 7. Why is this 4, 5, 6, 7? Because 0, 1, 0, 0. Okay, this is 4. This is going to be 6, 7, and then this is going to be from AB. Sorry. So from AB we have 1, 0. From CD there is 0, 0. So 1, 0, 0, 0 is 8, 9, 10, 11, and then 12, 13, 14, 15. Okay, so you can, if you want, you don't need to write the combinations, you can write the numbers serially from the next examples. Okay, after we write the mean terms, can somebody tell me what should be the next step after drawing the chart? Guys, what should be the next step?
We should mark down the mean terms.
Right, we should circle the mean terms. So here the mean terms are 1, 3, 5. So 1, 3, 5, 11, 13, 15. So 11, 13, 11, 13, and 15. After we're done circling the mean terms, in the next part we will have to figure out what goes through each input. So this column represents input number 0. So input number 0, nothing is circled. So if nothing is circled, what do we pass through input number 0? If nothing is circled, can you look at the previous example? If nothing is circled, what do we pass?
Then 0.
Right, if nothing is circled, then we pass 0. Okay, from input number 1, if and now, okay, so if nothing is circled, we pass 1. If all of these were circled, then we would have passed 1. Okay, that's the thumb rule. Now if some are circled and some are not, then we write the equation. Okay, so for input number 1, let's see, so for input 1, first let's go for mean term 1. So mean term 1 means a bar, b bar. So mean term 1, we will take the variables of a, b. So from input number 1, since 1 is circled, 1 corresponds to a bar, b bar. Then we have the second one, 5. For 5 it is a bar, b. For 13 it is ab. Okay, and then we will simplify it. So if we can simplify this by taking a bar as common. So if we take a bar as common, wait, this was a bar, b bar, right? Okay, if we take a bar as common, then b will go away because b plus b bar, then we will have ab. And then if we simplify it further, what will we get?
A bar plus a.
So we have a bar plus a
and a bar plus b
into a bar plus b. So what do we get here?
A bar plus b.
A bar plus b. Okay, this is what will go through input 1. So input 1, I will have a bar plus b. How about for input 2? What will pass through input 2?
Then 0.
0. And input 3, can you simplify this?
Then we'll have a plus b bar.
Right, it is a plus b bar. Okay, next part would be after doing this. This is input number 0, 1, 2, 3. So from input number 0 and 2, input 0 to 0 will pass. So we will, from 0 to, we will ground it. Okay, and then for a, b, if we have a here, let's say I have a bar here. So for input number 1, I'll have a bar plus b. So a bar plus b, it will be OR. And then the next part, we will have a plus b bar. So we'll have a plus b bar. Okay, and this will pass through another OR gate. Okay, it's a bit unclear. Okay, draw the OR gate properly, make sure it shows, and this will go through 3. Okay, for the shorted lines, make sure you show the circle. Okay, so this will be the construction for the implementation of the circuit f of a, b, c, d, and using a 4 to 1 marks. Always remember that you draw this chart when selector bits are less, number of selector bits is less than number of inputs. Okay, so if there are 2 selector bits, you're left with 2 MSB, 2 extra input, and those should be manipulated using the chart. If you had 1, then the chart would have looked different. Okay, all right, so does anybody have any question here? Okay, if not, I will move on to the next part. Next part we will construct bigger marks using smaller ones. So we will construct four to one marks using 2 to 1 marks. Okay, so in such a case, first what we will do is we'll draw the 4 to 1 marks. So again, 4 to 1 marks has 4 inputs and it has 2 selector bits and 1 output, right? We need to construct this using our 2 to 1 marks. Now since 4 to 1 marks needs to have 4 inputs, how many input does our 2 to 1 marks have?
Ma'am, 2.
Right, it has 2 inputs. So since I need 4 inputs, how many 2 to 1 marks do I need?
1, 2.
Right, we will need two to 1 marks because I need 4 inputs, right? So 2 inputs will come from here and 2 inputs will come from here, and it will be 1 output. So this will be 0, 1. So for this marks it will be 0, 1, but for us overall this should be 0, 1, like it should have 0, 1, 2, 3, right? This will be 0, 1, and this will be input number 2, and this will be input number 3. Okay, now see, now I have 2 outputs, but overall how many outputs should be there?
1.
1. So what we will do is, since we get 2 outputs here, one of these outputs will be shown as the overall output, so I will need another 2 to 1 marks here. Okay, so this will be 0 and 1, and this will give me the output. Okay, why do we do this? We will see later. Okay, because out of these two outputs, only one should be selected as my overall output, because my overall output should be 1, and these marks have 1 selector bit. Okay, we are almost done, but we have one part left, that is, overall we should have only 2 selector bits, right? So the selector bits of these marks, they will be shorted. Okay, this will act as 1 selector bit, and this will work as the other selector bit. Okay, because there should be 2 selector bits, S2 and S1. Sorry, S2 and S1. So remember, for the initial for these marks in the first stages, the inputs should be shorted. That is, selector bits of this will be the same as selector bit. The same selector bits should pass through the first marks, and for the later marks this will be another selector bit. Okay, so whatever I pass through this selector bit, the same thing will pass through this selector bit as well. Now the question is, which one is S2 and which one is S1? Okay, so what do you guys think? Which one is S2 and which one is S1? Any guess? Which one is S2 and which one is S1?
Well, the right one is this one.
Okay, so it looks like this left one is S2 and this one is S1, right? But let's check it first. So if I give 1, 0 in S2, if I give 1, 0, which output should be chosen?
2.
Line number 2 should be chosen, right? Like input 2 should be as an output, so input 2 should be chosen. But let's see if 2 gets chosen or not. So if I pass 1 through this selector and 0 through this selector, 2 should be chosen. But let's see. So if I'm passing 1, 1 goes from here and 1 goes from here. So from here, which line is being chosen?
On line number 1.
Okay, and from here, which line is chosen? Line number 1, which corresponds to line number 3, right? Which represents line number 3. So 3 will be chosen. And if I pass 0 here, which is chosen?
Line number 0.
0, and from 0, 1 is being passed, right? So input number 1 is being chosen. So this input is actually being chosen. So I'm passing 0, I'm passing 1 and 0, but line number 2 is not being chosen. Which one is being chosen? Line number 1 is being chosen, right? So what do you think? Which one is S2 and S1? If I'm giving 1, 0, then 1 is being chosen. So what I'm actually passing? Am I not passing 0, 1? Because when I'm passing 1 0, if this is S2 and this is S1, then 2 should have been chosen, right? But I'm seeing that 1 is being chosen. If 1 is being chosen, this means 0 1 is being passed, right? This means 0 is being passed through S2 and 1 is being passed through S1. So in reality, is this S2 and is this S1?
No, ma'am.
Then what is it? It's actually the opposite, right?
Yes, ma'am.
So when we construct the marks this way, the bit that comes later, this is working as the MSB, so this is S2 and this is actually S1. Okay, so if I have to, because if I have to pass 0 1, then I pass S0 through S2, so 0 through here and 1 through here, then I get input 1 is being selected. Okay, now let's change our input. So say if I want 2 to be selected, then I need to pass 1 0. So from S2 I need to pass 1. Okay, I need to pass 1 through S2 and I need to pass 0 through S1. Now let's see, if I pass 0 through this part for the first section, if I pass 0 from this part which is being chosen, which input will be chosen?
Line number 0.
Right. So line number 0 will be chosen, and if I pass 0 from here, which is going to be chosen?
Line number 2.
Line number 2 is going to be chosen. And since I'm passing 1 from S2, then which will be chosen from here?
2.
Line number 1 will be chosen, right? Because I'm passing 1, and through line number 1, what do I have passed? I have input number 2 passed. So whatever I pass to this will be selected. So whatever I pass to this part, it's being passed from to here, and then ultimately input number 2 will be chosen and given as the output. Okay, so remember, in the initial stage, the marks that you have, they will hold the LSB. Okay, they will hold the LSB, and the marks that comes later, that will hold the MSB. So this is actually S2 and this is actually S1. Okay, whenever you construct marks, you must show the selector bits. You should show which selector bit is MSB and which selector bit is LSB. Alright, does anybody have any question here? Okay, if you don't have any question, now we will do the opposite. We will build a bigger marks using a smaller one. Okay, so we will build 2-to-1 marks using 4-to-1 marks. Okay, so again we will draw this. We will need to build a 2-to-1 marks. This means 2 inputs and 1 output, and it should have 1 selector, and I need to use a 4-to-1 marks. 4-to-1 marks means it has 4 inputs, 2 selector bits and 1 output. So this is input number, this is input number 0, 1, 2, 3. Okay. Alright, so it should have 1 selector bit, right? So S2, S1, it should have only 1 selector bit. 2-to-1 marks. So we need to convert this marks into this. Okay, so what we can do is we will ground S2. So if we ground S2, S2 will always be 0, right? And we will change S1. So if we give S1 as 1, if S1 as 0, then input number 0 will be selected. And if we give S1 as 1, then input 1 will be selected. And since S2 is grounded, input number 2 and 3 will never be selected. Okay, so we can discard these inputs. We will not need them, and S2 will be grounded. In that way, we only have S1, and depending on the value of S1, either input number 0 or 1 will be selected. Okay, so if I pass 0 1 from here, input number 1 will be given as the output. Okay, so this is how we can convert a bigger marks to smaller one by grounding the MSB. Is this clear, everybody? Does anyone have a question? So I find this relatively easier. If you have to build a smaller marks using bigger one, then you don't need multiple. Okay, you just need 1 marks, but you need to ground the MSB because you don't need the MSB. Because I have S2, S1 here. If I only need to pass 1 if I only need to use S1, then I will just turn the MSB to 0 and then I can change S1. Okay, if I have more number of bits, we can always put MSB as 0 and the number will still stay the same. Okay, so we're done with the examples of marks. Does anybody have any question on this part? Okay, one student had a question in the last class that what do we do with these inputs? Now, if you want, you can ground them or you can make them high. It does not matter, because as long as S2 is 0, these inputs will never be chosen, because to choose input 2, you need to pass 1, 0. For 3, you need to pass 1, 1. For that, S2 has to be 1, right? Now, S2, since S2 is grounded, 2 and 3 can never appear in my output. Okay, now let's move on to the next segment, where we will see the application of encoder and decoder. So you need to convert you need to construct a 2's complement converter of 3-bit numbers using encoder and decoder. Okay, this means that I will give you a 3-bit input, okay, a 3-bit binary number, okay, this should be binary. I'll give you a 3-bit input and you need to give me the 2's complement of that 3-bit output, okay. So I'll have input here and I'll have output, okay. The input is of 3 bits. So if we have 3 bits, how many combinations can we have for 3 bits? 8. So it can be 0, 0, 0, 0, 0, 0, 1, then 0, 1, 0, then 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, and 1, 1, 1. These are my 3-bit input, right? And my output should be the 2's complement of that number. So what is the 2's complement for 000? Guys, what's the 2's complement for 000? Hello? What's the 2's complement for 000?
Only 1, 1, 0.
How do we convert the 2's complement?
Ma'am, 000 কি থাকবে?
Of course. How do we convert from 2's complement? We keep the bits same until we find a 1, right? We start from the MSB until we find 1. We keep all the bits same. So it's going to be 000. What will be the 2's complement for this combination? 001.
Ma'am, 111.
Right. We keep the bits till we find 1. So 1 will stay the same and this will be turned 1. So it's going to be 111. What will be for this?
110.
110. For this it's going to be 101. For this, what will be the output?
100.
Then this
011.
then this 010, and ultimately this will be
001.
01. Okay, all right. So I want for each of this input, if I give this as the input, if I give 011 as input, I want 101 as my output. Okay, all right. So now let's see how we can construct this with encoder and decoder. Now my input needs to be in binary, okay, and my output needs to be in binary. So between the decoder and encoder, which one takes the input in binary? Which takes a binary input? Guys, between the encoder and decoder, which one takes the input in binary?
Ma'am, encoder and decoder.
Encoder does not take input in binary. Decoders take input in binary. Okay. A decoder takes a binary input and converts it into its decimal value. So over in the this is a 3-bit input, right? So which decoder should I use here? Guys, 3:8 decoder. 3:8 decoder. So it will have 3 inputs. If it has 3 inputs, it will have 8 outputs. Okay, the outputs being 0, 1, 2 up till 8. Sorry, up till 8 now. Right, up till 7. So 3, 4, 5, 6, and 7. Okay, this is the 3:8 decoder. And my output, so what will happen is the decoder will take this as input and it will pass it to the encoder. Okay, in an encoder, so if I have to draw the encoder, it's going to be an 8 to 3 encoder. This is an encoder and this is a decoder. Okay, and this is the encoder. So this encoder, it has 8 inputs, that is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so from 0, 1, 2, 3, 4, 5, 6, 7, and 3-bit output. Okay. Okay, now let's see. Let's say my input is, let's say my input is 0, 1, 1. So if I give 0, 1, 1, what do I want my output to be?
Well, 0 kind of 1.
No, what do I want
Well,
my output
3 is gonna
what do I want my overall output to be? If my input is 0, 1, 1, what do I want my output to be? 1, 0, 1.
1, 0, 1.
I want my output to be 1, 0, 1. So let's see how can I bring the output as 1, 0, 1. So if this is 0, 1, 1 in a decoder, this is 3, right? So 1 will pass out of output number 1, and the rest of the output will be 0, right? This is how a decoder works. One output is 1 passes through the only one output, rest of the output will be 0. Okay, and if so 3 is selected, so 1 will pass out of 3. So if I want 1, 0, 1, I need to pass the 3 through the combination of 1, 0, 1. 1, 0, 1 is 5, right? So 3 will be connected with input number 5. In this way, if I pass 1 here, 1 will go through 5, and in an encoder, if 1 goes through 5, then my output will be the combination for 5. So 5 is 1, 0, 1. So if I give 3 as an input, my output will be 5. Now let's do the rest of it. So if my input is 0, my output should be 0, right? So 0 will be connected with 0. And if my input is 1, what will be my output? If my input is 1, my combination will correspond to which decimal number? 7. So 1 will be connected with 7. 2 will be connected with whom?
6.
Right. 2 will be connected with 6. 3 with 5. Okay. 4 will be connected with 4. 5 will be connected with 3. See, 5 corresponds to 3. So 5 will be connected with 3. 6 will be connected with 2, and 7 will be connected with 1. Okay. Now let's see, if I pass 0, 1, 1, then 1 passes through 3 and 3 is connected with 5, so 1 will pass through 5. And since the rest of the outputs is 0, in the decoder, rest of the input will be 0. Okay? Remember, in a normal encoder, you have input in the inputs, you should have 1 passing through only one input. Rest of the input should be 0. Okay? So 1 passes through 5, rest of the input is 0. So as a result, the output will be the combination of 5, which is 1, 0, 1. So if I give 0, 1, 1 as input, my output will be 1, 0. If I give 0, 1, 1 as my input, my output will be where is it? My output will be 1, 0, 1. Okay, this will be my output. So anyway, this is how we can construct a decoder using encoder and decoder to construct a 2's complement number, 2's complement converter. Okay, let's do another example for the input and output. Let's say I'm giving 2 as my input. Okay, I'm giving 2. So for 2, it's going to be 0, 1, 0. Okay, it's going to be 0, 1, 0. So 0, 1, 0 means 2. 1 will pass out of input number 2. Okay, so let me drop this off. Okay, so if I give 2 as an input, 1 will pass out of output number 2 and rest of it will be 0. As a result, since 2 is connected with 6, 1 will pass into 6 and the rest of the inputs will be 0. So as a result, in this encoder, all the inputs are 0 except for 6. So my output will be the combination for 6, which is 1, 1, 0. So if I give 0, 1, 0, the output will be 1, 1, 0, which is the 2's complement for 0, 1, 0. If I convert 0, 1, 0 to its 2's complement, it's going to be 1, 1, 0. Okay, so whatever I put here, I will get the 2's complement. But why did it happen? Because I have made the connection in this way. Okay, the connections have been made in this way. That's why this is how it will work. Okay, does anybody have any question here? Does anybody have any question? Okay, if nobody has a question, I will take your attendance.
ম্যাম এটা রিয়েল লাইফে করার সময় কি ওয়্যার দিয়ে কানেক্ট করতে হয়?
Yes, you will need wires to connect. Is there anyone from section 1 here? Anyone from section 1? Okay, I am taking your attendance. Section 12. Said Mahmood, Niloy Palit, Miraz, Salwa.
Present, ma'am.
Tell me your name.
Salwa.
Abrar Fuad, Anika Firdaus. Anika, I think you were present last class, right? Rakibur Rahman, Soeb Sultan, Sami Abdullah.
And Samia.
Samia, why did you attend the class at the last moment?